Hello, welcome to my channel. I'm Lima Alpha 6, November Charlie Alpha. In this video I will show you this rare spy radio.
At first glance, this looks like an ordinary suitcase from the 1940s. A traveler might have carried it on a train or a bus. No one would suspect its true purpose. But inside this humble leather case is a secret. This is a Swedish agent radio built by Johan Lagercrantz in Stockholm during World War II. It was designed for one thing only: clandestine communication. Let's take a closer look at the engineering inside. Let's examine the storage compartment in the front panel. Inside, I found a set of headphones. They appear to be German. Also stored here is a small bulb and spare tubes still in their original paper wrappers. Interestingly, a German-style Morse key is mounted directly to the main panel. As you can see, this Morse key is of German manufacture. During World War II, neutral Sweden actually purchased a significant amount of military radio equipment from Germany. This included components like this key, but also complete stations like the Torn FUB, and even Feld Hellschreiber machines, which I actually have in my own collection. Lagercrantz likely used these available German parts when assembling this radio. Next to it, we see a crystal holder. This is the frequency determining element for the transmitter, and it is marked 3640 kilohertz, which is within the 80-meter band. The left side of the panel is the receiver. Here is the main tuning knob and a band spread control for fine adjustments. We also have an audio volume knob and a regeneration control, which was vital for sensitive reception. The right side is the transmitter. We can see the antenna tuner with coil tapping selections and a tuning capacitor. Next is a switch for a small bulb. This was used to check for maximum antenna current when tuning the transmitter. Finally, here is the connector for the wire antenna. On the front panel, there is also a calibration chart for the receiver. This table shows exactly where to set the dials for a specific frequency. So, who used a secret radio like this during the war? It is highly likely that this unit belonged to XU. XU was the largest and most secretive Allied intelligence organization in occupied Norge. Their mission was not sabotage, but pure espionage, gathering critical information about German troop movements and fortifications. Because they operated under extreme secrecy, they had their own supply lines through neutral Sweden. This battery-powered Lagercrantz suitcase radio was ideal for XU agents. It allowed them to transmit heavy intelligence reports back to Stockholm and Great Britain from hidden locations, completely independent of the power grid. Now, let's look underneath the panel. The top plate is actually hinged, allowing easy access to the components inside. This clever design meant that an agent in the field could easily perform maintenance or change a tube without needing special tools. I have placed a very important book here in the lid. It is written by Erling Langemyr and is titled Radio During and After the Occupation. This book is a fantastic source of knowledge for Norwegian wartime radio history. As we turn the pages, we can find the exact circuit diagram and the technical data for this specific Lagercrantz radio. Let's take a closer look at the schematic to see how the circuit is designed. Now, let's look at the complete circuit diagram for the entire radio. On the left side, we have the transmitter section with the two DLL21 tubes. Moving over to the right side, we can see the receiver circuit, utilizing the three 1D5 tubes. And finally, on the far right, we find the power supply connections. The radio requires a 3-volt supply for the tube filaments and a 135-volt high-tension supply for the anodes. Let's take a look at how this transmitter circuit is designed. The circuit uses two DLL21 tubes. Inside these two tubes, there are actually 4 pentodes in total, and all of them are connected in parallel to get more power. Now, let's switch over to the schematic diagram. Looking at the schematic, the quartz crystal is connected directly to grid number 1. Grid number 2 goes straight to the 135-volt power. The anode is also connected to 135 volts, but through a radio frequency choke. From the anode, a capacitor couples the signal into an LC-tuned circuit. This variable tuning capacitor is 500 picofarads. The coil is a large air wound type with 11 different taps. By turning the switch to a different tap, the operator could match the impedance of the antenna wire. Finally, in series with the antenna output, we find the small indicator bulb used for tuning. You might wonder, what kind of oscillator is this, and where is the feedback loop to start the oscillation? This is a Pierce crystal oscillator. There is no visible feedback wire on the schematic because the feedback happens inside the vacuum tubes. The signal is fed back from the anode to the grid through the tube's own internal capacitance. When the anode coil is tuned correctly, this creates the perfect positive feedback needed to start the oscillation. Now, let's move over to the receiver section. Here on the top side of the chassis, we can see the 3 1D5 tubes, the main tuning capacitor, and the RF coils. When we look underneath the panel, we find all the smaller components, like resistors and capacitors, neatly wired together. Let's look at the receiver circuit. It consists of 3 vacuum tubes. First, we have an RF input amplifier. Next is a regenerative detector, and finally an audio output amplifier. The tubes run on a 1.5 volt filament supply and a 135 volt anode supply. At grid number 1 of the first tube, we find an LC circuit with a coil and the main tuning capacitor. The antenna is coupled into this circuit using a separate winding on the outside of the coil. The second tube uses a similar LC circuit on its grid. The anode of the first tube delivers the RF signal into this second LC circuit, also through a separate coupling winding on the coil. Tube number 2 provides feedback to create regeneration. A 50 picofarads capacitor goes from the anode of tube 2 back to the anode of tube 1, right into that extra winding. To control this, screen grid number 2 has a potentiometer. This allows the operator to adjust the voltage from 0 to 130 volts. By turning this, we change the gain until the circuit oscillates, making it possible to decode CW or Morse code signals. Finally, the audio signal travels from the anode of tube 2 to grid number 1 of tube 3, which is our audio amplifier. The headphones are connected directly to this final anode through a coupling capacitor. Now that we have covered the schematic, let's look at where the batteries are stored. One half of the suitcase space is dedicated entirely to the battery compartment. By lifting up the main radio chassis, we reveal a wooden dividing wall. When we swing this wooden partition out of the way, we can see directly into the battery room. Inside, there are several wires with small connectors ready to plug into the batteries. First, we see the space for the 345-volt anode batteries, which are wired in series using these connectors. Deeper inside, we find the wires and plugs for the two 1.5-volt filament batteries. For the final test, I have connected the filament voltage and the high tension to the radio using my laboratory power supplies. I have also connected my dipole antenna. When I turned it on, the receiver actually worked right away. It is absolutely fantastic that a radio this old can come to life so easily. The build quality from the 1940s is truly impressive. Now, let's see if the transmitter works as well. I flip the switch to the transmit position and press down the Morse key. Look at that! The small indicator bulb wired in series with the antenna lights up immediately. By turning the 11-position rotary switch, I can find the best coil tap for my antenna. Then I adjust the variable capacitor until the bulb glows with maximum brightness. This confirms that the transmitter is perfectly tuned and pushing maximum power into the antenna. Now, it is time for the ultimate test, a real over-the-air contact. I have arranged a schedule on 3,640 kilohertz with my friend, LA5BT, located in Larvik. He hasn't operated Morse code in years, so this is a great challenge. Let's start the transmission. I will send out a call. CQDLA6NCA. Listen to that. He is coming through. The radio is performing beautifully. The contact was a success. The audio quality from this Lagercrantz transmitter is remarkably clean, and the receiver did a fantastic job. It is incredible to think that this completely unmarked suitcase radio, built in secrecy for the XU network, is still fully operational today. Thank you so much for watching this video. If you enjoyed this piece of radio history, please hit the like button and subscribe to the channel. This is LA6NCA, signing off. 73.